Good morning. This lesson is for my Integrated 1 and my Honors Integrated 2 class. This is lesson 5 in solving equations. But before I get started, I want to say I hope everybody is doing okay out there. Let's go ahead and go over our goals today. We have 3 goals that we want to hit. Our first goal is we're going to review the distributive property. Our second goal is we're going to create a final list of steps to solve the equation, to solve linear equations. And our last goal is to do a couple examples of these 6 steps. Now, I don't know if I've made this clear or not, but I would like you to get in the habit of writing down our goals in your notes for every lesson. And so I'm going to make that worth a point on the assignment, is you have to write down the goals for the lessons. I want to make sure that when you look back at your notes, it's clear what the day's lessons were about. So I need to see the goals to get full credit. Otherwise, instead of a 5 out of 5, I'll give you a 4 out of 5. All right, so our first goal right today is to review the distributive property, and distribute means literally to pass out, right? So if you work at a distribution center, you are passing out whatever product you are storing or that is coming through your warehouse. So again, distribute means to pass out. Not fall asleep, but to hand out. All right, anyways. So the distributive property, I have 2 examples. And the full name of the distributive property, kind of like the name Chris and Christopher. The full name of the distributive property is the distributive property of multiplication over addition. It's a long name, right? But it's really easy to use. So 3 is multiplying by both to both of these terms. And so we distribute the 3, or pass out the 3 to both terms. And we get that after we distribute the 3, we get 3 times x is 3x. And 3 times 2 is positive 6. That is using the distributive property. We are passing out the 3. In the second example, what I've done is I've made the number that we're going to distribute or pass out negative. And so we're going to pass out or distribute a negative 2 to a positive 3x and a negative 5. So we need to pay attention to the sign. Negative 2 times positive 3x is negative 6x. And negative 2 times negative 5 is positive 10. So this is just an example of the distributive property of multiplication over addition. Even though this is a minus sign, it's still the technical name. All right, so I am going to check off our first goal. And I'm going to move into the second goal, and I really want you to write this entire second goal on your cheat sheet. And we'll go through each of the steps. And I've also noted which of the steps are repeatable. And I've also gone into a little bit more detail about each step. And the hope is that we begin to recognize the differences, for example, between step 3 and step 4. And in step 5, I added a little bit more detail as well. And hopefully this helps us to really grasp the fact that when I ask you to solve equations, I'm only asking you to literally do 6 things. That's all I can ask you. I can ask you to solve an infinite number of equations, linear equations with 1 variable, but the reality is I can only ask you to do 6 steps. And so if we look at mathematics not as an infinite number of problems, but boil it down to what 6 things can be done to this problem, hopefully it alleviates the stress of the vastness of the potential number of homework problems that I could give you. And so let's go ahead and go through these again. If there's a blue star next to the step number, that means it can be repeated. Our first step is going to be to eliminate fractions, and we do that by multiplying everyone by the denominator. So I'm telling you how to eliminate fractions in the first step. Second step is our new goal today is to distribute. Third step is to combine like terms on each side of the equal sign. I put this in here because a common mistake is students get combining like terms on each side of the equal sign mixed up with getting all variables to one side of the equal sign. And so I wanted to stress the fact that you can only work on one side of the equal sign for step 3. Step 4, we're going to get all variables to one side of the equal sign. Remember that solve for 5 problem we use addition or subtraction to move variables to the other side. Step 5 is we're going to add or subtract a weighted number from the variable side of the equal sign. And step 6 is we're going to divide away a number. That doesn't mean hashtag, that means a number. That means a number, not hashtag, right? So we're in a math class, so I'm going to say that means number, not hashtag. I'm looking for my marker. All right, so I'm going to check off the second goal. I'm going to step to the side for a second, give you a chance to pause the screen so that you can write this down. All right, this is really an important goal for this class's ability to solve an equation, but I am going to check off the second goal. There are, you can solve equations in different orders, but it's just my experience that this order tends to be the best. Remember, we saw that if you divide first, you create fractions. We don't want to create fractions. All right, let's move on to goal number 3. We're going to do examples of the 6 steps of that we use to solve equations, right? So I would get in the habit of writing numbers next to the problem. Step 1, step 2, step 3, step 4, step 5, and step 6. And again, I want to remind you guys, I came up with these 6 steps, I articulated them because a lot of students ask such a good question. How do you know what to do? When do you know what to do? And so I felt that when I was asked this question, I was caught off guard because it was such a good question that I didn't have answered in the lessons. And so I had to create these 6 steps to solve equations. And I do see a lot of strong skill sets from my students when we realize that we just have to work our way through these steps. If you can do the step, do it. If not, move on to the next. Remember, there's a possibility that the first 3 steps can be repeated, which reminds me about my friend named Pete, who had a son named Pete, and they call themselves Pete and Repeat. But anyways, back to this. Some of the steps can be repeated. You work your way from top to bottom, and at the very last step, you should have an isolated variable, and you will solve your linear equation in one variable. All right, so let's see here. I'm just going to go through the steps. Step 1 says eliminate fractions by multiplying everyone by the denominator. I do not have fractions in this problem, so that means that I can't do step 1. So I'm going to put an X next to step 1, which means I'm on to step 2. Step 2 says to distribute. When you see parentheses, that is your clue that you're going to distribute. And in fact, I see that I can distribute twice. I can distribute on the left side, and I can distribute on the right side. So 2 times x becomes 2x. 2 times minus 3 becomes minus 6 plus 4. And then I get 3 times x becomes 3x. Oh, I lost my x right there. 4x. And then 3 times 6 becomes 18. So I did the second step twice. I distributed twice. Now I'm moving on to my third step. And my third step says to combine like terms on each side of the equal sign. So what I like to do is I like to just draw like a little barrier between the left side of the equation and the right side of the equation, and I look to see if there's anybody I can put together, anybody who's a like term. And in fact, 2x and 4x, those are like terms. And so I'm going to now have 6x. Those are put together. I can't put that together with anyone else, so that stays a minus 6. Let me look on this side. I can't combine the 3x with the 18 or the 18 with the 3x, so this is going to stay as it is. Okay, so I did step 3 once. Step 4 comes along and says get all variables to one side of the equal sign. All right, I have a 6x on the left side. I have a 3x on the other side. I want to move, it doesn't, to be honest, you can move them in whatever direction you want. But in thinking a couple moves ahead, I know that to get rid of this 3x, I have to subtract it to both sides. And I'm going to have a positive result because my larger number is positive. So I'm going to move the 3x to this side of the equal sign. I'm doing step 4. And I'm going to do that by subtraction. So minus 3x to both sides. That 3x cancels. I'm left with 6x. I'm sorry, I'm going to subtract. I'm left with 3x minus 6. That's equal to 18. Okay, so I did step 4. Step 5 comes along and says add or subtract away a number, not a hashtag, add or subtract away a number from the variable side of the equal sign. So again, if I just draw a little wall, this is the variable side of the equal sign. You should only have 3 terms for this step. This one you should have 4 terms. So this algorithm, we call it, forces step 4 to have 4 terms, step 5 to have 3 terms, and step 6 to have 2 terms. So it's nice. You know you're doing it right if that's happening. So step 5 says add or subtract away a number from the variable side of the equal sign. So I'm gonna, the minus 6 is on the variable side of the equal sign, so I gotta add that to both sides. I'm gonna add the plus 6 to both sides. The minus 6 and the plus 6 cancel, and I'm now left with 3x is equal to 24. So I'll put a check next to that 5. And I'm on to my last step, which is divide away a number. The number attached to the x is 3. I'm going to divide that to both sides. And that means that my x is equal to 3 goes into 24 8 times. So my value of x is 8. I've done step 6. So when I create problems for you to do, I'm not creating problems out of thin air where it's like, what numbers can I put in this equation? I'm legitimately creating problems where I want to see, like here, I wanted to see steps 2, 3, 4, 5, and 6. And that's how I design problems. I think about what steps I want you to do, and then I create a problem that has those steps in it. So if we look at solving equations as 6 steps, I tend to believe, and I hope that it simplifies this for you and it answers the question that some of you guys have is, what step do I use and when do I know to use it? And this system of solving hopefully answers that question for you and hopefully simplifies it for you. So I do have another example. I just don't want this lesson to go on too long. I want to see where I'm at time-wise, 13 minutes. I'll do this next one really quick, and I will show you another problem here. And so again, like I said, when I design problems, I'm thinking about what steps I want you to use, right? And so I have this problem of x over 5 equals 7 minus x over 2. So again, we go through our 6 steps, and I'm looking to see if we can do certain steps on this problem. So like right off the bat, I'll tell you that I know that this is a step 1 problem, this is a step 4 problem, and this is a step 6 problem. 1, 4, 6. Let's see if I'm right. Alright, so step 1 says eliminate the fractions, multiply everyone by the denominator. I can actually do that step twice, and just to speed up things, I will do it pretty quick. I'm going to ignore that 2 and multiply everybody through by a 5. Alright, so now I get that cancels, and I'm left with x. 5 times 7 is 35, minus 5x over 2. I'm going to repeat that step. I'm going to multiply everybody through now by 2. So you get a 2, you get a 2, and you get a 2. These 2's cancel, and now I'm left with 2x equals to 70 minus 5x. So I did step 1 twice. Can I distribute? No, there's no parentheses. Can I combine like terms on each side of the equal sign? I don't have anyone to put together with the 2x, and these aren't like terms, so I can't do step 3. Can I get all variables to one side of the equal sign? Yes, I can. And I can do that by adding 5x to both sides. You might want to bring the 2x over, which is fine, but then you're going to have to bring the 70 over in step 5. So just kind of thinking ahead a couple steps, you want to get the variables to the other side away from the numbers, right? So let's get them over here. So I'm going to add 5x to both sides. And so now I'm left with 7x, now I'm left with 7x is equal to 70 because these guys cancel out. And I just did step 4. I can't add or subtract away a number from the variable side of the equal sign. There's no one for me to add or subtract away from the 7x, so I can't do step 5. But I can do step 6, and that's to divide away a number. That's not a negative. So then that means x is equal to 7 goes into 70 10 times. Right, so again, I said that I made a problem that was a 1, 4, 6. There we go. So I hope that this helps us solve equations. I really do. I hope it simplifies it for us. So that's this lesson for today. Again, I hope everyone's doing okay out there. I will see you next time. Have a good day.